welcome everybody to a very special day of CSI 40. We're going to do trivia, C++ trivia. And what you guys are going to do is you're going to be given 5 seconds to answer each one of these questions. I'm going to count on my fingers to 5. And when I say, give me the answer, you're going to type in A, B, C, D, or E. E meaning does not compile. All questions have an implicit E does not compile on them. I don't type this out, but you can, actually let me put this up in nano because you can see off the left-hand side there. My IntelliSense would maybe give some of this away. So all questions have an implicit E does not compile. I'm not gonna, have it typed up here, but you can give that as an answer for each and every one of these questions as well. Okay, and so we're going to do this for fun and profit. All right, you guys ready? So here in global space, we have question -1. Yes, we're starting counting from -1, not just 0, because this is a troll quiz. Okay, so I'm going to count to 5, and you're going to give me A, B, C, D, or E as the answer. A, you believe that foo is initialized to 0. B, it is undefined behavior, what it is initialized to. C, it will not compile if you try scouting foo without initializing it. And D, some other thing is true. Or E, this will not compile at all. Okay. So on the count of 5, 1 and a 2 and a 3 and a 4 and a 5. Everybody type their answers. B, 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 C, C, A, C, B, B, A, A, B, C, B. Answer is cut off. A is correct. All right. So if you have a global in C++, it will be initialized to 0. This is not true for regular variables. Regular variables, meaning stack variables, are not initialized by default. So if you have integer foo inside of a function, the value is, I don't know, something. It'll be something. It will compile. It will compile, but you'll get some number. It's unclear what you'll get. This is something in C++ we call UB, or undefined behavior. If you see out the value of an uninitialized variable, you will get something. We don't know what. But for globals are all initialized to 0, guaranteed. All right. Next, free response. What does this line of code do? Now, at the very bottom of the file, there's a matching close brace, so it does not compile. If you're assuming it doesn't compile because it's missing a close brace, that's not a concern. There is, in fact, a close brace at the very bottom of the file. So you have 10 seconds because this is free response, and I guess I'll pause the recording. Write a sentence. What is this line of code doing? Begin. And a 1. And we're back. Type the answer on chat. Main is declared an int. I don't know, to be honest. This is essentially just int main. Return an int function. Pointer to use int. Declares int main using auto and pointer to int. So this is just a fancy way. IDK, IDK, IDK. All right, answers are now cut off. The answer is, this is exactly the same as writing int main. Remember the first week of school? Exact same thing. Some people like it this way, though, because it makes them feel smart. So, no, but seriously, there's a lot of C++ people that will write their functions this way. So auto, and this is saying that the return value is int. So it's like writing int main, just with more steps. I don't agree with it, but it is valid C++. Let's move on. Next up, we have question 1. Free response. What is this line of code doing? I1 minus equals -1. Begin. And we're back. Answers are cut off. So, decrease the value of 1, -1, I plus, I1 plus 1, minus, minus. This is the exact same thing as if I had written, sorry, I'm not in Vim, I1 plus plus. Exact same code. Yep. It is just the professional gamer way of doing an I++. Minus equals -1 subtracts -1 from the variable, which is the same thing as adding 1 to it. Okay. You will see that on like programmer memes and things like that. It's better because it's symmetrical. See, you don't have to worry about, do I do ++ I? Do I do I++? Which one? It's symmetrical. Minus equals -1 is the way of the future. All right. So, and yeah, I am kind of trolling. Okay. So, what is this going to print to the screen? You guys have 5 seconds to give me the answer. Don't sue me for copyright, Jeopardy. What is this going to print to the screen? What's going to print to the screen? 5 seconds. 5 seconds is up. Quick, quick, Luke, type fast, quick, type. With a 1 or an exclamation 1? Question mark, 1, or question mark, exclamation? Which one was that supposed to be, Luke? Exclamation. Okay. Answers are cut off. What this will print to the screen? This will print out cout, double left arrow, vertical slash, obviously. Obviously, I think we all can see why. Right? We all know why this is a vertical slash, right? You knew something was up? So this it does not work in more recent versions of C++. That's why I stated it is compiled in C++11 mode. I think C++11 was the last time that trigraphs were allowed to exist. And so these things are called trigraphs, and they date back to the 1970s, I think, like prehistoric times. The reason why they exist is because back then, not all keyboards had like a vertical slash like key on them. And so you needed a way to be able to type things like vertical slash using symbols that you were guaranteed to have on your keyboard, like question mark. And so the community hates them, right? Because like, you know, people would type something like non-vim, non-e, you know, like that, and it would print out non-e vertical slash, and you're like, what? You know, what? Because it, you know, it just is common sense. It would print question mark, exclamation mark. But IBM, from what I recall, fought the removal of trigraphs for years because they had, from what I understand, trigraphs all throughout their code base. And so at some point, the C++ Standards Committee just said, just do a search and replace, please. Just figure it out. You consult for other companies, consult on your own company. Do a search and replace. And they removed them from the standards. So this will no longer print vertical slash anymore in modern C++. Okay, next. This is an example that John Kolb gave at CPPCon. CPPCon is, of course, the global international conference for C++. And it's a great conference. I've been to it a bunch of times. And you have some of the best, you know, C++ professors and, you know, professionals and educators and specialists in the world there. And when you put this question up on a slide, well, I'll let you guys answer it first, and then I'll tell you what I answered, then I'll tell you what most people answered, and I'll tell you what the right answer is. Okay, so 5 seconds. Okay, let's read it first. So, unsigned integer x is equal to 1. We have an integer y is equal to -1, and we are comparing x and y. So if x is less than y, we're going to say 1 is less than -1. If x is equal to y, then 1 is equal to -1. Otherwise, 1 is greater than -1. Okay? And the last option is, of course, E does not compile. Now, this will probably throw a warning, which is, again, why I have my Vim turned off so that it doesn't highlight things for me. But it'll probably throw a warning, but it's not, you know, I'll just give you this one. It's not an error. It will compile. So, 5 seconds. Which one do you think the answer is? Is 1 less than -1? Is 1 equal to -1? Is 1 greater than -1? A count of 5. All right, we got C, C, A, B, C, C, B, A, C, C, C. Why would you guys say 1 is equal to -1? That doesn't even make sense. Shin, Bean. Which one do you guys think? C, C, C. It's a trick question. It is not a trick question. Answers are cut off. The answer is, of course, A. 1 is less than -1. Now, you might be surprised by that. You're like, how can 1 be less than -1? And the answer is, if you compare a signed and unsigned integer together, C++, which inherited this behavior from C, so somebody back in the 1970s decided this is how the language should work without really thinking about it, and we've been stuck with it ever since. So if you compare a signed and an unsigned integer together, the signed integer, y, that guy, gets converted to an unsigned integer, and it immediately underflows. And so the -1 turns into 4.2 billion and change. And guess what? 1 is less than 4.2 billion and change. Shouldn't work that way. In my opinion, shouldn't work. Shouldn't. You should just be able to compare signed and unsigned integers, and as long as you're not out in the 2 billion range where they don't work, I think it should just work, is my take on it. But what do I know? I'm not Dennis Ritchie. So the answer is A. Next up, we have ASCII. Do you guys remember your ASCII codes? So input tester for part 1 is broken for input file 16 and output file 16. I'll take a look at this. Okay, so we have a variable named A that is equal to capital B. We've got a variable named lowercase b that is equal to lowercase a. If capital A is greater than lowercase b, then cout B is greater than A. Else if capital A double equals lowercase b, then cout B, capital B, is equal to lowercase a. Otherwise, print out C, capital B, is less than lowercase a. You have 5 seconds. You have 5 seconds. You can begin. And 2 people are typing, 1 person's typing, and finished. End. Okay. The answer is capital B is less than lowercase a. So in the ASCII table, if you take a look at the ASCII table, let's not save that maybe. If you go to man ASCII, you can see that uppercase B has a value of 66, and lowercase a has a value of 97. So capital B is less than lowercase a. Next up, another one of those. So you should all be able to get this one, because I just showed you the ASCII table and you were all paying attention. Capital A is equal to capital A now. How nice is that? Lowercase b, though, is now equal to lowercase a. And so you want to know, is capital A greater than lowercase b? Is capital A equal to lowercase b? Or is it less than? So put your answers in now. And we'll try to find the meme that inspired this. And we're back. This is the one that inspired me from Who Wants to Be a Millionaire? All right. So, what is the first letter in the alphabet? A, B, B, C, C, D, D, A, D. Is that your final answer? Yes. Okay. So for this one, the answer is in fact A. Looks like most of you guys got the one correct. Very good. Very good. Very good. Okay. Next up, integers and floats. So, do you guys remember how to do integer division? Do you remember how to do floating point division? Do you remember the rules? The Pirates Code. Okay. So we've got integer f is equal to 5.0 divided by 2. We have floating point I, which is equal to 5 divided by 2. And we're asking which is bigger, I or f. So normally I would name a float f and an integer I, but here they're backwards. So I'll give you guys 5 seconds on this one as well. ... on chat. So which one's bigger, I or F? 1, 2, 3. And ended. Okay. So you guys are saying that I is greater than F. Except one person said I is equal to F. You are almost all wrong. Cutting off the answers now. The answer is B. The reason for this is because 5.0 divided by 2 is what? 2.5, right? And then if you take 2.5 and you shove it into an integer, what does 2.5 turn into? Remember, this calculation over here does not look at the left side. It doesn't. This expression is evaluated first. So we do floating point division. We get 2.5. We try shoving it into an integer, and it turns into 2. It does not round. It cuts off the it cuts off the decimal. And this is why I'm doing this quiz for you guys. It's not just for my own personal amusement, although it is. It's because this is actually a great way of learning sort of the trivia. You know, this isn't even trivia. This is actually something you really need to know. Some of the things I'm doing are definitely trivia. But this you really actually need to know. Now, what is I going to be set to? I is a floating point number, right? So what is I going to be set to? What do you guys think? It's a float. If you divide 5 by 2 and store it into a float, it should be 2.5, right? No, you're all wrong. Because I just told you guys this, right? 5 is an integer, 2 is an integer. It computes the expression first. It doesn't know what the storage type is. It doesn't know that it's going into a float or not. It doesn't know. If you ever divide an integer by an integer, you do integer division. And 5 divided by 2 is 2, not 2.5. Then the 2, integer 2, gets stored into floating point I, the variable here. So it's saved as 2.0, not 2.5. And so we have 2 is equal to 2.0. You might be a little bit nervous about that because it's a floating point number and you should never do equality with a floating point number, but in this case, it'll actually save it exactly as the number 2 and the comparison is valid. So the answer for this is B. All right, next up, pointer math. Now this one is undefined behavior, so you know, if you don't get it right, it's fine. So we've got a pointer X. We are then advancing the pointer to point to the next variable. This is undefined behavior. We then dereference the pointer, and we ask you if the value is greater than 1, equal to 1, or less than 1. So if you guys forget where X and Y were, if we scroll up here, you can see that X is equal to 1, and the variable next to it is Y, and Y is equal to -1. It's not guaranteed that this works, by the way. But let's assume if you have a pointer to X and you plus it, it'll point to Y. Not guaranteed, though. Okay, it's got a pointer now pointing to int Y equals -1. Okay, so if you dereference that, what do you get? Do you get a value that is greater than 1? Do you get a value that is equal to 1? Or do you get a value that is less than 1? Enter your answers now. 5 seconds. A, B, B, A, ABBA. Need a man after midnight. C, B, B, A, another ABBA. Almost. All right. So the answer is, of course, A. And the reason why -1 is greater than 1 when you dereference it is because we have here a unsigned integer pointer. If we have it point at Y and Y holds -1, it immediately underflows and becomes maximum integer for unsigned integers. It's 4.2 billion and change. The answer is A. -1, when converted to an unsigned integer, is the biggest possible 32-bit number, holdable in a unsigned integer. All right, you guys having fun? You guys learning stuff? You guys enjoying this? Having good times right now? Yeah? No? Thanksgiving's tomorrow. You're having fun? You managed to fail both ASCII questions. even after I showed you the ASCII table. Yeah, this is I mean, I explicitly ordered you all to have fun. Why are you not having fun? Oh, I was expecting that one from the Brooklyn Nine-Nine. Okay. All right, there we go. So we have foo holding hexadecimal number, FF. And if you guys know what hex is, it is a base 16 numeric system. So 0xFF. This is not 0 times FF, if you're wondering. It is saying it is 2 hex digits. So I'll even show you what this looks like on your calculator. Here, if we go to programmer mode and switch to hex mode, type in FF, you'll see the value of this is 255. Okay. So it's 8 ones. Every hex digit is 4 binary digits. So this is 1111, 1111. So a bunch of zeros and then 8 ones, which turns into 255 in decimal. So the question is asking, who is bigger? Foo, which is FF, or bar, which is 4 Fs and then 4 Fs. So this is a 32-bit number. You have 32 ones all in a row there. So what is the answer? Is FF greater than FFFF, FFFF? Is FF equal to FFFF, FFFF? Or is foo less than FFFF? And a 5, and a 4, and a 3, and a 2, and a 1, and time is up. So the answer is, of course, A. So you might be like, well, wait, that's more ones. Shouldn't it be a bigger number? If it was an unsigned integer, it would. As it turns out, this is -1 in signed integer world. If this was an unsigned integer, it would be 4.2 billion and change. This is actually what -1 looks like in hexadecimal. So -1 is less than 255. All right, next up. Here we have a for loop, and inside of the for loop, we are making a class. The name of the class is not there. This class has 2 public member variables named Q and R. And we're making a variable of type whatever that is, and initializing it to 1, 1. We say that's the first part of the for loop. Then we say bob.q is less than 10, bob.q plus plus. Inside of the for loop, we double bob.r every time the for loop runs, assuming it runs at all, and this code compiles. If bob.r equals 512, tripped is false. If bob.r equals 256, tripped is true. Bob.r equals 1024, tripped is true. Bob.r is 2048, tripped is false. Otherwise, tripped is false. At the end of this for loop, assuming it compiles it all, is tripped true or false. I'm going to pause this one and let you guys think about it a little bit. And we're back. So remember, E is always an option, does not compile. Just, for those of you that want to go with that. All right, cutting off now. So this does in fact compile. You can actually, in fact, make a class with no name, like horse with no name, that kind of thing. And so you can make a variable of a class type at the same time that you declare the class. This is why, actually, incidentally, you need to have a semicolon at the end of a class declaration. When you say class foo and you put a semicolon there, the reason why the semicolon is there is because you actually have the option of declaring variables x, y, and z of type foo when you declare the class. That's why there's a semicolon. And like I said, this is kind of a troll quiz, but at the same time, it's actually educational and stuff like that. So what we got here is a for loop. How many times is for loop going to run? If you have a for loop going from 1 to less than 10, starting at 1, going to less than 10, how many times does this for loop run? Remember, the normal pattern is starting at 0, going to less than 10 is 10 times. So we're starting 1 higher, so we're doing 1 less loop, so it's going to run 9 times. Okay? This is why we follow the standard pattern for for loops so that we can make quick deductions like this. So 9 times it's going to do the following. It's going to take Bob's R value, which starts at 1, and multiply it by 2. So we're computing powers of 2. So the number of times we do the loop is the power of 2 that we're going to be. So we're going to be 2 to the 9th power, which is 512. And so the answer is B, tripped is false. I think. All right. Moving on, we've got iota. So we've got an array, a C-style array, boo hiss, that is of size 10. All the elements in the array are initialized to 0. We then call the iota function on the array. From the beginning to the end of the array, starting at 1 with the iota. We then do a try-catch block. We did exceptions last time. There we go. Maybe there is an exception. Maybe there's not. Who knows? Okay. And we are going to try to access array element 4 square bracket array. If 4 square bracket array is greater than 4, we're going to see out 4 square bracket array is greater than 4. If 4 square bracket array is equal to 4, we're going to print out 4 square bracket array equals 4. Otherwise, we're going to print out 4 square bracket array is less than 4. If it throws, if any of these lines throw, then it's going to print out D, 4 square bracket array, through an exception, or E, if you look at this and suspect that this cannot possibly compile, the answer would be E. So, 5 seconds. What's the answer? All right. Not too many responses on this one. And okay, now we got some more responses. A lot of A's, some C's, and a B. The answer is in fact A. Okay, and the reason for that is because in C++ and C, you can actually write the array and the index in the array interchangeably, because an array, we talked about this a couple weeks ago, array square bracket 4 actually just turns into dereference array plus 4, like that. And so if you do 4 square bracket array, this actually turns into 4 plus array, which is cumulative. So it actually does not matter which order you write the things in, although people will absolutely guaranteed hate you if you write your code like this. Promised. It's job security code, though. So, and then we ioted it. Iota is going to set the first element of the array to 1, the second element of the array to 2, the third to 3, the fourth to 4, the fifth to 5th, so on and so forth. So array square bracket 4 is the 5th element in the array, so it is equal to 5. And 5 is greater than 4, so A is in fact the answer. Okay. Next, variable shadowing. Okay, and we're also testing if you can make variables inside of an if statement. So integer Bob equals 5, integer x equals 0. Remember, we had an integer x up above. It was equal to -1. Integer Bob equals 12. We're going to see out x is equal to something. Else if and y equals 1, we're going to see out y is equal to something. Otherwise, we're going to print out b, x is not equal to x and y is not equal to y, or e does not compile. Think about it and give me your answers. And we are back. So this is going to create a new variable. You can, in fact, create a variable inside of an if statement now. In modern C++, you can do this. In older C++, you cannot. So this is making a new variable named x, and it's fine. You can actually make a variable with the same name in 2 different scopes, whichever scope, as long as they're in different scopes. And whichever scope you're in, the closer one is the one that counts. So if I was to output the value of Bob here, the value is going to be 12. If I output the value of Bob here, the value is going to be 5. right? Because this Bob only lives within this scope. So if I were to print out the value of Bob here, Bob would be 5. Here, Bob is 12. You guys understand? So you can have the same variable in different scopes, and whichever one is closer to you is the one that you see. And you can't really see the other ones, which is why variable shadowing is in general considered a bad idea, though yesterday when I was writing a quad tree implementation, I may or may not have shadowed a variable or two. Okay, so when you say integer x equals 0, that is an assignment operation. It sets x equals 0. But whenever you do an assignment, it actually returns the value as well. Is 0 true or false? When we say integer x equals 0, are we returning true or false? What is 0? Is 0 true or is 0 false in C++? It is false. Okay. The rule in C++ is false is 0. Everything that is not 0 is true. -1 is true. 1 is true. 2 is true. We traditionally think of 1 as being true and 0 as being false, but technically anything not 0 is true. So the number 5 is true. Okay. And so here we say if integer y equals 1 is true, and we could say here like 5 or something like that. That would be fine, right? Good job, Nano. Okay, all right. So if we did this, it wouldn't change anything, right? Because y is true. It returns 5. 5 is true. It's going to print out b. B is the correct answer here. All right. Next up, comma operator. This is a part of C++ most people don't know about, or if they do know about it, they know it poorly. I'm just going to put this up here. I'm not going to say anything. I'll explain it after you guys guess wildly on whether the answer is A, B, or E. Does not compile. I'm pausing it now. And we are back. So the comma operator in C++ works a lot like a semicolon. So for that line I have highlighted there, that is, interchangeably the same as saying x equals 5, semicolon. Y equals 10, semicolon. Okay. What is different, what separates the comma operator from the semicolon is you can't really put a semicolon in expressions. An expression is anything you can put parentheses around. Okay. So, right, if you said x is equal to parentheses 2 times 10 plus 7, everything between the parentheses there is called an expression. Now, you can put commas in an expression. You cannot put a semicolon in an expression. Like, it would be really weird if you had this, right? This would be like the compiler would just have an aneurysm and die, right? If you tried doing this. You guys understand? Like, this looks really weird to me. And it should look really weird to you, even though this is your first computer science class for most of you. Do you guys see that? Like, that's weird, right? Having a semicolon in the middle of an expression like that. Comma, though, can go there. And so what the comma does in an expression is the entire expression will evaluate to the last thing that you have commas on. Okay? So it allows you effectively to do multiple things inside of an expression. That's like saying x equals y, semicolon. Set x equal to y. It then compares x equal to y. This does nothing because we're not doing anything with the return value of it, comma, and then this whole expression is going to evaluate to false because the last thing in the comma separated values is false. And so if we did this line here, what value is x going to get? What do you guys think? If I say x is equal to 2 times 10 plus 7, comma, 10, what value is x going to get? Yeah, 10 is correct. Okay. And you might be like, why would you write code like this? Like for that highlighted line, I would never write code that way. It's pointless. I've got, I'm doing math that I'm not catching the return value on. Like, yeah, I would never write code this way unless I'm just like deliberately trying to troll students or something like that, right? Job security. But sometimes you actually want to do something like set x equal to y and then do a comparison or something, or do a function call. And if you have a function call that's like a void function, you normally can't put You cannot normally put a void function into an if statement because they don't return a value. You can't put them into an if statement. So if you have a function call, you could do something like if, foo, something like that, comma, x is less than y or something like that. You can do that. And then what's going to happen is that it's going to call that function. Maybe it's a method on a class or something. And maybe it sets the values of x and y. Maybe these are member functions. And so you can call a function and then compare the member values or whatever member variables afterwards. That's actually a use for the comma operator. Okay. And if you remember this in ASCII 26, it'll help you. We do code golf, in which you try to minimize the number of semicolons in your code. You get extra credit based on how many semicolons from your code you can eliminate. And so up to 150% extra credit. So if you guys take me for ASCII 26 next fall, here's a gift for you. Okay? A lot of extra credit next semester. Or next year. Okay. 2 semesters from now. Next, bonus round, last question. If I minus I is greater than I minus minus I, see out I minus I is greater than I minus minus I. If I minus 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 I is greater than I minus 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 I, see out I minus 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 I is greater than I minus 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 I. Otherwise, C. Okay, I don't want to say it anymore. Or E does not compile. So, yeah, we do a little trolling. So, I'll let you guys think about this for 2 seconds. All right, 1 1000, 2 1000. Give me your answer: A, B, C, or E. The students' reactions on Discord are amazing. That's an Increment after the guy's dog got pitched off the Coronado Bridge. Okay, so the answer is, of course, B. So I think you can all see why, right? I think it's pretty obvious why the answer is B. So, so the way that analog literals work is that the number of dashes you have between the i's is literally the size of the number. So this is like saying, is 1 greater than 3? No, it's not. Is 5 greater than 3? Yes, it is. So the answer is B. And they have 2-dimensional analog literals as well, and 3D ones as well, where you literally draw a cube in ASCII. And you can compare one of those cubes you draw in ASCII against another size cube, and whichever one has the greater volume is bigger. So it's a real thing. Nobody uses it, but it's a real thing. This is actual code that works. So yes, to finish here, the answer is all of these things compile. By the way, std equals C++11 main.cc. All of these things. Ooh, did it not compile? Did I break something? I did break something. Right. Dim main. I should not have saved that because I broke this. Yes, thank you. Okay. It compiles. Yes, there we go. Okay. Yes, it compiles. All right. And practical use is 0, but it's fun. And as today is the last day before Thanksgiving, we all just want to have fun, like the rascal who dreams of Bunny Girl Senpai. So I have some good news for you, which is, do any of you guys, show of hands on Discord or not, if you don't want to out yourself, does anybody have any Zybooks, Zylabs, or homework assignments that you do not have 100% on? Just give your hands up emoji, something like that. So, have I got a deal for you? We have a special deal for you. And the special deal is called GG Easy No Ray. This is very similar to the Sound of Music doe, a deer, a female deer. So let me bring up lab time for today. No, not you. What did I click on? GG Easy No Ray. Let's try that. There we go. Great. So what you have to do for lab time today, and you actually have till midnight on Sunday, midnight on the end of Thanksgiving break to finish this. Find a homework assignment, which could be a programming assignment. It could be a Zybooks or a Zylabs. No quizzes. I do not want to go back and go through old quizzes. It is too much effort. But any programming assignment, any Zybooks, any Zylabs that you did not get 100% on, you have to write a paragraph about why you did not get 100% on it. For example, on Pokemon, I didn't understand that string to integer stoy would throw an exception on end of file. Something like that. I want you guys to engage in some meta cognition where you actually think about, it could just be like one student was like, I had a wedding to go to and I couldn't make it. That's fine. Okay. I just want you to engage in a little bit of metacognition. Write a paragraph why you were not able to 100% it, and then you have until midnight on Sunday, Thanksgiving Sunday, midnight, to redo it. And if you redo it, you will get 100% on it. All right. So, yeah, it is worth 100,000 points in a category that is weighted at 0%. So. So, but seriously, the lab itself doesn't count for anything today because if there's some people that have just done all the homework, and that's fine. There is no lab time points. Instead, what you're doing for lab time is reflecting on past homework assignments that you potatoed on. Think about why you potatoed on it. Like, I didn't understand at the time how a for loop worked, and I do now. And so you can go back to Warui, or you can go back to Calculator if you want. Any of these things you potatoed on, and you know better now, you're going to have an opportunity to go back and redo them, fix them, screenshot yourself at 100%, and GTG, you're good to go. Weeks 15 Zybooks and Labs is torture. Was that the one on sorting? I know the one on sorting sucked. And in fact, I'm getting feedback to the Zybooks people on that one. If it's a debugging assignment, yeah, there is no input tester on that, so you're going to have to just write that you've done it, and then I will have to grade it and see if you did, in fact, get it right. So the whole point of the debugging assignment is that you don't have an input tester. You have to go through the debugging process yourself. So you have to be very, very careful on that one. Merge sort of quick sort. Yeah, the one on Zybooks and Zylabs. Yeah, I'm probably going to pull that out next year, and I'm going to leave feedback for them because it was not well written. Yeah. So that is class for today. You don't have to do this right now. You have until Sunday at midnight, and feel free to ask for help on the help section. And obviously, don't plagiarize code, things like that. Don't just have people write your code for you. But if you need help, the Discord server will be open all through Thanksgiving. The tutorial center, however, will not. There is no tutoring available at the tutorial center. Through Sunday. It's closed. So if you want help on this, post on the help center here on Discord, and I or McRelly or a tutor or one of the alumni will probably help you. I don't know. I'm on vacation, but I do check on Discord and I'll help you. For Zylabs, would you explain each part of the lab? Yeah, if you weren't able to do one of the labs, explain why you weren't able to do it. I didn't get how file IO works. I want you engaging that process inside of your head of like thinking about your thinking, which is one of the most important skills that you can have in life. I mean, it's useful as a student, and it's especially useful if you are a person who is optimistic, which is normally a great trait in life to be optimistic. But when it comes to programming, people are oftentimes optimistic in their abilities to complete a homework assignment on time, and then they schedule it poorly and potato. Okay. Sidebooks, you go back and complete the part you didn't get done. That's correct. Yep. Anything you did not get a 10 out of 10 on, 100%, whatever. Go back, do it. Begin. Go. What are you waiting for? Go. Have a great Thanksgiving too. Bye.